The form sheet of the FMEA looks like this by default. So it's identified all the components, and if you click on this drawer, it lists out all the failure modes. In this case, it's identified three failure modes for the left side camera. Again, all of this is generated by the tool. The user is not doing anything in generating the failure mode. The tool is capable of generating a failure mode. Right now, it's doing it based on a database. The user also has the ability to add more failure modes. Now, if you look at the left side camera, we've identified three failure modes, or the tool has identified three failure modes: corrupted camera frames, missing camera frames, and frozen camera frames. Now, if you want to add another failure mode, this can be done over here. You could say new failure mode, and then you go ahead and add it, and it just pops up over here. And or if you want to edit this existing failure mode, you can do that. Then if I click on this drawer, a bunch of things open up. And what it's doing is the following. If there is a corrupted camera frame, what is the effect? Now, we know if there is a corrupted camera frame, the effect is partially rendered images. Will there be a loss of image? No. Will there be a delay of image? No. It's going to be partially rendered image. So that would mean this has 01 and has 02 are not applicable for corrupted camera frame. So I can just straight away go and delete as 01. I can also delete as a 02. Okay, so then I have hazard 03, and then I need to predict what is the severity. With hazard 03, which is there is a corrupted image, the risk is the driver is unable to detect an object on the side. Driver is unable to detect an object on the side. And there's going to be a safety critical issue. And then I say this is definitely 10. And you can see the severity automatically adjusts wherever the same hazard exists. Also, the severity rationale changes the same way. Then, then we have a list of causes. Causes again is automatically predicted by the tool. It says over here, the cause of this could be some EMI interference, or the cause of this could be just wrong calibration. Yeah, we've chosen the wrong pixel format, which means the could be either on the CPU side or it could be either on the camera side. We just chosen the wrong format. Now, let's say we want to rate this. We give it for this cause. We say it is low because state of the art EMI tests are performed. And then, so now we have, and then we'll go into talking about the safety mechanism if there is a corrupted frame. So if there is a corrupted frame, we do have a safety mechanism for this, which is a corrupted frame monitoring. So basically, this is the corrupted frame monitoring is we are assuming that it's already existing in the safety concept. And if it's not existing in the safety concept, then we'll have to go and add. And I'll come to that in a bit. Corrupted frame monitoring, it just looks at this, checksum, the line CRC or the frame CRC on the camera frame, and then it sees there is a problem, and then it would inform the driver. I'm going to say here the detectability is two. I'm going to say it's a high detectability. uh, high diagnostic coverage is available, and then I'm going to say the recommended action is nothing. What this means is we have an RPM of 40, the action priority is medium. Probably don't need to do anything about this. And I'm also going to change the status of this to now complete. Or I could just set it to in review. Next, we're going to look at another failure mode. Actually, the same failure mode, but another cause. And you see that it just pop. It's written down as the second row over here. In this case, the cause is the wrong pixeling format. The causes are different, but the effect is the same. We're going to have this issue over and over again where we have multiple causes leading to the same effect. We could uh, we now have to decide what is the measure, whether we need to have separate mechanisms to detect the cause and the effect, or is it just sufficient to detect the effect. In the second case, we have a wrong pixeling format. Let's say the occurrence of this is, I'm going to say 2, because there is a calibration check to see the format of the camera data. This is an example of design prevention control. You could do a lot of other things, like you could either assign it to testing can detect this, so it has good diagnostic coverage. This is an example. And then again, the safety mechanism here again, we could say, actually, I'm going to change this to a 4 just to show that there is some difference. And again, here, let's say if we wanted to add a safety mechanism over here that is different from what is going on over here, what we would do is we would go to effects, then we would add a new safety mechanism. Now I'm going to say new SM. I would say add. It comes up over here, and then I go back to the form sheet, and then I click on this. This is now going to show up as a new safety mechanism. So I would then, it's automatically saved, and then in terms of detectability, I'm going to give it a rating of 2. This is just an example showing how the tool can be used. Diagnostic coverage, and then once this is done, I would also change this to in review. And in the recommended actions, we would say new safety mechanism to be added in. Let's see. So here's an example. That's an example of how to do the FMEA here. Now, one of the features that we're working on is the ability to add requirements directly here, and then we should be able to click a button, and then it should go directly into the requirements management tool. That's a work in progress. Now, I want to give you a little overview of uh, the filtering feature that we have, which is highly recommended. It's a very well it helps a lot. Just because FMEA has hundreds of rows, so many columns. This feature is what is going to make things easy for the user. So if I want to select only the ones that are in review, so I can just do this, and then it would say, look, these are the only two that are in review, and everything else means it's in draft or it's in, so I could say progress, and then you would see pretty much everything is in progress. Now, the other feature that I wanted to show you is the metrics. So once all of the FMEA is done, you can have some metrics on the action priority numbers. You can have some metrics on the RPN distribution, severity occurrence, severity and detectability. Now, at this point, we've just rated, let's say, three rows. That there's one default rating which we haven't done, so it's just showing up over here. These are metrics that one can use to say, okay, how many low, medium, and high priorities do I have? So then you can decide what are the failure modes that I need to act on, what are the failure modes that I don't need to act on. Whether you want to use action priority or the RPN distribution, action priorities become the new go-to standard to determine whether we need to mitigate the risks or not. Some people also use RPNs. Some people also use more than just RPNs. It's severity and occurrence, it's severity and detectability, and they have thresholds to say, oh, if it's more than 100, if the RPN is more than 100 or 125, then we have to do something about